Second lesson on sequences and series. We're going to learn what an arithmetic sequence is and how to find the nth term and the sum of terms in arithmetic sequences and series. Right, to start off with then, work out the first four terms of this sequence. You should be able to do this, following on from what we did last lesson. We've got the first term given. We're told how to find the next term from any given term. We simply add 4 each time. So the first term is 2, and by adding 4 we get 6, 10, 14. This type of sequence is called an arithmetic sequence. An arithmetic sequence is where from one term to the next we are going up by the same amount each time. So we can see there that in this instance we're going up by 4 each time. So by definition, an arithmetic sequence is where to get from one term to the next term you add the same number each time, which we call the common difference. Okay, have a quick look at these and decide which of these 5 sequences are arithmetic sequences. Okay, well hopefully you worked out that actually there's only 2 here. There's this one here. Okay, it goes down by 4 each time, but that's like adding -4, so that counts. That's an arithmetic sequence. And this one here where it goes up by 11 each time. These 3 don't work. Give them a try with some numbers if you're not sure, and we'll discuss these in a bit more detail in the lesson. Well, if we call the first term A, and we use this definition here, we get from one term to the next term by adding D, then UN is going to be A plus n minus 1 lots of D. And we can see that here, can't we? To get to the 5th term, it's 3 plus 4 times the common difference of 10. To get to the 4th term, it's 3 plus 3 times the common difference of 10, and so on. So there's our general nth term formula. It's very important, but it is given in the formula booklet, so you don't necessarily need to memorise it, although the more familiar you are with it, the better. We can use it to work out how many terms there are in this finite sequence. Have a go if you like, pause the presentation and have a try. The key to these sort of problems is to write down the formula and write down everything you know. So let's plug all those values into the formula. The only unknown is the n, that's what we're looking for. So we get 348 equals 3 plus 5 times n minus 1. Multiply out the bracket, we get this. Rearrange, we get 5n equals 350, which tells us that n is 70. Okay, so that's the nth term. What about the sum of n terms? So how many cans are there in this pyramid? Simple. We can count that easily and see there's 10 cans. How many cans are there in the pyramid with 100 cans on the bottom row though? Well, it's not as difficult as you might think to work that out quickly and easily. So an arithmetic series is what we call the sum of terms in an arithmetic sequence. So when we start adding the terms together, we call it a series. So that's an arithmetic series. This is a sequence. So back to the pyramid. That's what we're looking to find the sum of, isn't it? We've got 1 can in the first row, 2 in the second, 3 in the third, and so on. Well, if we write the same list out in reverse, we get this. And if we add this first term from both of them, which is actually the first here and the last here, isn't it? And we keep going on like that, we discover that it always adds up to the same thing. We get 101 each time. But how many times have we done that? We've done it 100 times, haven't we? And we end up with that. It's important to remember, though, that we've doubled our value because we've added the same numbers to our original sum. So to find the answer, we simply need to halve that. So that didn't take long, did it? Have a go yourselves. Work out, using a similar logic, the sum of the first 50 positive integers and work out the sum of all the odd numbers between 21 and 99. Well, this is our basic formula. We're adding the first and the last, like we did with the 100 and the 1. And we're then multiplying by a half of the number of terms. Because we're pairing up, that's what we need to do. So here's our formula, and here it's in terms of the sum of n terms. This is given in the formula booklet. Because we've got a formula for the nth term, instead of L for the last term, we can use that formula. And we get an alternative formula there for the sum of n terms. It's exactly the same as this one, but this one's often more useful. If you don't know what the last term is, then this one's more useful. So there we are, 2 formulae, but again both given in the formula booklet. Right, have a go at this one. If you're successful, then you're ready for the lesson. Pause the presentation and have a go. Okay, so same technique as before. Write down everything you know. You know the first term, simple to work out the common difference. You know the last term, well, we'll call that the nth term. Use the formula for the nth term. From that, you can work out how many terms there are. We get 11 plus 4n minus 4. Well, that gives us 7 plus 4n on the right hand side, doesn't it? So clearly 4n is 100, so n must be 25. So we can now put the values there directly into our formula. This one's usually the easiest. If you know this value, it's definitely the easiest. And we get a sum of 1,475.